This is a training on LightningCast probability, a tool to predict when lightning might happen that was developed with machine learning tools. I'm Scott Lindstrom from CIMMS. John CINTINEO from CIMMS, now at NSSL, was the main force in developing this tool. The GLM observes lightning. Human interpretation of ABI imagery has been shown to be important for nowcasting lightning, especially lightning initiation. You've likely seen examples that use the day-cloud phase distinction RGB and how its color changes to highlight phase changes that precede lightning, as shown in the right-hand image here. Maybe you've read Elsenheimer and Gravel. To create LightningCast, a portion of the historical ABI and GLM data record, at first just in 2019, was used to train a machine learning algorithm to analyze multispectral ABI imagery with the goal of nowcasting lightning as observed by GLM. To repeat, you take current ABI observations and future GLM observations and train a model based on the ABI data to predict when the lightning will occur. LightningCast works day and night. It uses 4 ABI bands on GOES 16 and GOES 18, bands 2, 5, 13, and 15. The output is the probability of a GLM observation in the next 60 minutes, and the output is remapped to about a 10-kilometer resolution grid that's similar to the GLM resolution on a lat-long grid. How might you use LightningCast? Some possibilities are on this slide. You can probably think of more. This is a clean example, CONUS scanning every 5 minutes, that shows variable lead time in the Midwest. Some of the cells take some time to produce lightning. Lead time is a function of showing how rapidly a storm develops. This is a more cluttered scene. This is mesoscanning with 1-minute data. An important point here is that although you almost always see LightningCast plotted over animations, time tendencies in ABI data are not used in the algorithm. It just looks at a single time observation of bands 2, 5, 13, and 15, and the information in those bands is used to predict whether GLM will observe lightning in the next 60 minutes. You can sometimes get a LightningCast signal even before radar signatures are showing up, as shown in this CONUS scan with 5-minute imagery. If you're expecting convective initiation, maybe look at LightningCast contours. This is a 2022 HWT example. If there is thick cirrus, as on the left image, LightningCast can't see the cloud structures that precede lightning. Neither can you. In this example, as soon as a tower penetrated the cirrus shield, in the middle image, LightningCast jumped, and 5 minutes later there was a GLM observation. What's new this year? That's listed on this slide. There's a web-based Lightning dashboard where you can make point requests for IDSS. LightningCast was retrained in the past year using more years of data, not just 2019. The latest version that you'll be looking at is better calibrated and has higher skill. Most importantly, in that orange box, probability thresholds are perhaps lower than what you're used to. There's also a new product, probability of 10 flashes in the next 60 minutes. What can you do this year at the website? So the URL is shown there. I hope you have it bookmarked. Click on the dashboard layer and red dots appear on the map. Most of these are airports, but there's some stadiums in there as well. Click on an airport or stadium and you'll see an identifier appear. Click on that link. The dashboard appears in a new tab. Several kinds of data are plotted. The red line is CONUS LightningCast probabilities. The yellow line is meso LightningCast probabilities. GLM flash centroids are also plotted with different colors for centroid sizes. There are also ways to toggle the meteorograms on or off and to change the airports and the times. Something new at HWT in 2024 is a request for a site for a readout. It's important to leave feedback for this kind of feature, whether you want to see it in real time or if you want to see it in operations. So if you like this, let us know. These curves show CSI. The red line shows values for the model being demonstrated this year, the orange line for the model demonstrated in previous years. The red line shows better CSI, that is, it's closer to the 1-1 point and further from 0-0. Note the numbers along these lines too, those are different. For 2024, the best CSI is with probabilities from 25 to 50%, versus 35 to 65% for previous years. In other words, if you've trained yourself to pull a trigger based on a probability in the past, you might need to adjust that. The calibration of the model has greatly improved. Previously, models were over-forecasting. On the right is the 2024 model reliability as a function of month. So you'll be looking at this in May and June, which is the green lines. There is a new product this year, a probability of greater than 10 flashes in the next 60 minutes. Currently, this is done for GOES East only. This figure shows that that's a lot harder to do. So the CSI is much smaller. But consider using this to capture weakening or strengthening ahead of GLM trends. Probability of 1 flash might be more useful to use as a storm is developing. The probability of 10 flashes is very well calibrated. There's a bit more spread in the reliability curves by month, however. Here's an example of the probability of 1 flash and the probability of 10 flashes. Sorry about those out there who are red-green or red-blue color deficient. It'll be hard to see the color of the contours. But this shows how you might use the products. Use the probability of 1 flash, and then if there's going to be significant intensification of the lightning, maybe the probability of 10 flashes is something you might want to look at. You have the ability to change the LightningCast contours, so they're easily configurable if you click on the localization pane. That brings up a window. Navigate through to Cave, and then Style Rules, and then the LightningCast Style Rules. You'll need to make a user file if there's not one there. If it's not there, right-click on Site and select Copy to User. One will be made for you. Then you want to open the user file. When it opens, you might be in the Design pane. You want to be in the Source pane. Do you see the two blocks of information? The one flash product doesn't have a name per se, it's the default. But the 10 flash product does. Both have values that can be edited. You can change the contours. You can change the color, the style, the thickness, the probability levels. You could add values here. So if you want more than 3, you could add a value of 2, for example, just to see when the LightningCast really starts predicting something. So you have choices. Don't do this while convection is firing, however, but this is something you might play with as you're waiting for convection to develop. Save the file, then you'll have to reload LightningCast products to see the changes. You really need feedback on this product. Carefully read this slide to see what will help. And as always, send questions and comments along. John CINTINEO is the main point of contact. Thanks for listening to this training.